In today's lesson, we will be covering the second part of chapter 2.4, where we are going to learn about the last 3 rules of indices. Just a quick recap on the first 3 rules that we learned in the previous video. Rule 1. When multiplying index expression with the same base, sum the powers. Rule 2. When dividing index expression with the same base, subtract the powers. Rule 3. Any value raised by the power of 0 is equals to 1. And now, we have a look at Rule 4. When raising an index expression by another index, multiply the powers. Let us again use some examples to see how it works. Have a look at x to the power of 3 raised by the power of 2. So, this whole thing means x cubed is repeatedly multiplied by itself for 2 times. And for the x cubed, similarly, the x is multiplied itself for 3 times, and finally we get x to the power of 6. Hopefully here you can see the first rule in action, where I added the powers together since they have the same base. So all of this shows you that if we multiply the powers together instead, we will get the same answer in the end, which is x raised by the power of 6. One more example I need to go through with you, and you want to pay attention for this one. Have a look at 2x raised by the power of 3 raised by the power of 4. The most important thing to take note about this expression is that the index 3 is not applied to the coefficient, but the index 4 is. Because only 4 here is applied to the entire bracket. And so to break down what's happening here is that the coefficient 2 and the variable x cubed is multiplied by itself for 4 times. We can also rewrite this as 2 to the power of 4 multiplied by x cubed to the power of 4. For this, if we multiply the powers for x, then x is raised by the power of 12. And 2 to the power of 4 is just 16, so your simplified expression would be 16x to the power of 12. So this 2x cubed to the power of 4, you don't ever want to confuse this as 2x cubed raised by the power of 3 multiplied by 4. Or even 2x raised by the power of 3 multiplied by 4. Because both of these will give you different answers and they are both incorrect. Hopefully that makes sense, and let's move on to the next rule. Rule 5. An expression with negative index can be expressed as the reciprocal of the positive. Reciprocal here means to flip the numerator and denominator position in a fraction. So if you have 5 over x, the reciprocal is x over 5, and if you have x, which is also x over 1, then the reciprocal is 1 over x. The rule looks like this. X to the power of negative m is equals to 1 over x to the power of m. Initially, the expression is raised by a negative index, and so we can rewrite it. We do a reciprocal, and then we change the index into a positive. To make sense of this, let's again look at an example. By now, you should know that when you're dividing index expressions with the same base, we can subtract the powers. So for this, x cubed divided by x to the power of 5, we can understand it as x raised by the power of 3 minus 5, which is equals to x to the power of negative 2. So now let's break this down. X cubed divided by x power of 5 is just basically x multiplied x divided by x multiplied by itself for 5 times, and we can simplify this by division to find ourselves 1 over x times x. Rewrite this back as an index expression and we get 1 over x squared. And so if our starting expression is the same, which is x cubed divided by x by power of 5, that must mean that x to the power of negative 2 is the same as 1 over x squared. So the rule says, if the expression has a negative index, we can re-express it as a reciprocal of the positive, which is exactly what we see here. The reciprocal of x to the power of negative 2 is 1 over x to the power of negative 2. But at the same time, we also want to let go of the negative index and replace it with a positive 1. And so finally, we do have 1 over x squared. The last rule for this chapter is Rule 6. Fractional indices is the root of the base number. If that doesn't make sense, just have a look at this example. We have x to the power of half times x to the power of half. So those are fractional indices. And we can apply the first rule to sum the powers, and we can find x raised by the power of half plus half. And then add them together, you get x raised by the power of 1, which is also x. In this example, in order to understand what is x raised by the power of half, we want to ask ourselves, what is two numbers multiplied by each other that returns the base number as the answer? Hopefully, square root x comes to your mind, because square root x multiplied square root x is just x. Just like square root 4 multiplied square root 4 is equals to 4. And with that, we can say that x to the power of half is equals to square root x. If you are unfamiliar with square roots, we have discussed about it in a previous video that will be linked in the description if you need to refresh on that topic. We can also say the same for the next example. Y to the power of 1/3 multiplied by y to the power of 1/3 multiplied by y to the power of 1/3. Same thing. We apply the rule to sum the powers. So y is raised by the power of 1/3 plus 1/3 plus 1/3. Everything added together is y to the power of 1, which is also equals to y. And then we ask ourselves again, what is a number multiplied by itself for 3 times that will return the base number as the answer? That is cube root y times cube root y times cube root y, which is equals to y. And therefore, we can say y raised by the power of 1/3 is a cube root y. The two examples that we have discussed can help us understand that any base number, if you raise it by a fractional index of 1 over any number, it is equals to the root of the base number by m, which is the denominator of the index fraction. So meaning to say, x to the power of 1 over m will always equals to root of x by m. One last example for this rule, which is also super important. Have a look at this. We know that x to the power of 1 over m is equals to root of x by m, where the index is a fraction of 1 over anything. And so, what if the fraction of the index is 2 over m, or 3 over m, or even just any number over m, like n over m? What are we supposed to do with the numerator n? It's actually not that complicated if we break it down like so. Take, for example, x to the power of 2 over 3. And technically 2 over 3 is just 2 multiplied by 1/3. And so we can rewrite our index expression as x squared raised by the power of 1/3. What are we doing here is sort of reversing the rule 4. Because normally when we see the expression like this, we can then apply the rule to multiply and simplify the expression. But in this case, we want to leave it like this and apply rule 6 instead. This means that the entire expression of x squared will be in a cube root. Then we can write it like this. X squared cube root. So in general terms, we can say that x raised by the power of n over m is equals to x to the power of n multiplied 1 over m. That is also just saying x to the power of n root by m, where m and n can be any number. Like, let's say, y to the power of 3 over 4 is y cubed to the power of 1 over 4, and so we can say y cubed root 4. There's one thing that I must mention. In exams, it is rarely the case that you will be asked to prove or show that a rule is true, but rather you will be tested on applying those rules to solve for the question. So your first priority is to know the rules and how to apply them. Knowing how to prove them true is secondary, but it's always good to understand how these rules came about. It's not just random things that people make up to make your lives difficult. It is rather the opposite, because those rules actually help you to simplify a lot of the process when we do calculations. And with that said, here is a summary of all the 6 rules that we have covered, and in the next video we will practice on applying them in questions. So that is it for this chapter covering the last 3 rules of indices. For any questions or concerns, you can check the description box or leave a comment below. And I will see you in the next video. Take care.